Hello friends, in this video let us discuss previous year electronic science paper which was conducted by UGCNET in the year June 2019. So in this video I am going to discuss question number 51 to question number 75. In my previous video I have discussed question number 1 to question number 50. If you have not watched that video, links are given in the description. Also you can click on I button. Starting with 51st question, what they have given is you have to arrange the input impedance of the devices in a particular order. We know that in the case of bipolar junction transistor, the input impedance will be a very low value, but in the case of MESFET, the input impedance will be a very high value. So based on this, if I am mapping, I will be getting BJT, nothing but first option will be 4 and MESFETs will be very much high value. So it is 1. The corresponding option that is going to follow is option 4. There lies a conflict between MOSFET and JFET. At low frequencies, MOSFET will be offering high input impedance when compared to JFET. In the case of high frequency, JFETs will be offering high input impedance when compared to MOSFET. But practical design, what you are going to do is, we are going to operate at very much high frequencies. So based on this, if I am choosing, I will be getting JFETs will be offering more input impedance when compared to MOSFET. But in general, if I am speaking, MOSFET will be offering more input impedance when compared to JFET. So this question I have encountered many times in my Telegram group. So this is what I want to convey. MOSFET will be offering very much high input impedance when compared to JFET. It is valid only at low frequency and medium frequency. But if I am talking about very much high frequency applications, at that time JFET will be offering more input impedance when compared to MOSFET. So based on this, option 4 is correct. In my previous video while recording, I just made a mistake, which is an invalid 8051 microcontroller instruction. They are asking move x at the rate of dptr, a. This instruction is an valid one. Since they are asking for an invalid, this statement will be a wrong. RA space A, this statement is an invalid statement. Move dptr, immediate value, this statement is correct. Since they are asking for invalid statement, statement 3 will be a wrong one. DA space A, nothing but DAA means decimal adjust after addition. But what they have given is a DAB. So this statement is an invalid. So for this, option 2 and option 4 is correct. Anyway, UGCNET has given a grace marks for this question. 52nd question, if the contents of accumulator AX is 4C26H, which of the following instruction will clear the contents of accumulator in the case of 8086 microprocessor? Not AX will be operating only on a bit, right? Not instruction will be operating only on a bit. But if I am talking about XOR AX, so this 4C26H, how can I write in binary means? What is 4? It is 0100. What is C? 1100. What is 2? 0010. 6, how can I write? It is 0110. So what they are performing is, they are performing XOR with the same data. 1100, 0010, 0110. Now what is the output of XOR gate when both the inputs are the same value? So when both the inputs are of same value, output is 0, right? Output is 0, nothing but XOR is going to give the output as 1 whenever inputs are unequal, but XOR will be giving the output as 1 whenever the inputs are equal. This is one trick what you have to remember. So if you are performing XOR AX, result will be stored back in AX register only. So what is the value of AX you are having? AX contents is 0. So this statement is correct. Sub AX, means you are going to perform AX minus AX. What is the answer you will be getting? You will be getting 0. That is stored in AX register. So statement B and C is correct. Nothing but option 2 is going to follow. Negation AX means, say suppose you are having 4C26. So what is negation of 0? It is 1. What is negation of 1? It is 0. So you will be getting the data which is something like this. What is negation of 0? It is 1. What is negation of 1? You will be getting 0. So this is the data what you will be getting. Nothing but 1011 means it is B3D9. So B3D9 is not equals to 0. So this statement is wrong. So the corresponding option that is going to follow is option 2 is correct. 53rd question, which of the following statement is not correct about universal shift register. We know that universal shift register is the one which is going to perform left shift or right shift by n bits. So you are in need of n D flip-flops to store the data, and it is bidirectional shift register. It can perform either left shift or it can perform right shift. It can perform serial shift or it can perform even parallel shift also. Since they are asking for not a correct statement, so first option can't be. Third option what they are given is we need n number of D flip-flops, yes, and n number of multiplexer to design n bit universal shift register. Even this statement is also correct, but since they are asking for not valid statement, so option C can't be. Universal shift register as a clear control that clears the contents of register to 0. Even this statement is also correct. See, in the case of universal shift register, you will be having preset and clear. If you are enabling this preset, you will be getting a register content as 1. If you are enabling the clear, you will be getting the register content as 0. Universal shift register generates internal clock, they are telling. So generating clock will not be in the hands of universal shift register to synchronize the operations, they are telling. So this statement is an invalid statement. So the corresponding option that is going to follow is option B is correct. 54th question, what they are given is the number of directed arcs terminating on any state of a state diagram is. First option what they are given is 2 power n, where n is the number of inputs, 2 power n, where n is the number of flip-flops that is used in the circuit, independent of number of inputs, dependent on number of outputs. So in order to explain this question, let me consider Mealy model or M-ary model. So in order to make a transition from S1 state to S2 state, what you are going to do is, in the case of Mealy model, you are going to represent the present input and what is the output you will be getting. That one you are going to represent in the case of Mealy model. But in the case of M-ary model, what you are going to represent is, you are going to represent the present state. You are not going to represent the output. So this is in the case of M-ary model. So 2 power n, where n is the number of inputs, it is independent of number of inputs and it is independent of number of flip-flops that is used. It is dependent on number of output. Even this statement is also wrong. The transition actually will be independent of number of inputs, right? One more thing what you have to remember is, in the case of M-ary model, you are in need of one more extra state in order to represent the output. So this is one thing what you have to remember, the basic difference between a Mealy model and a M-ary model you should know. 55th question, if the forward bias is applied to the diode, holes are injected from P side to N side, the concentration Pn of holes in the N side above its thermal equilibrium, that is Pn of 0, is given by, it is given by Pn naught plus Pn of 0 exponent of minus x divided by Lp. So this minus sign indicates that there is a decrease in concentration gradient. So the corresponding option that is going to follow is option 3 is correct. 56th question, in the case of X-ray lithography, if S is the size of the X-ray source and G is the gap between wafer and mask and D is the distance between source and the mask, then the blur is given by, it is given by GS divided by D. So the corresponding option that is going to follow is option B is correct. 57th question, following are few statements regarding noise in communication system. First option what they are given is atmosphere noise, short noise and solar noise are examples for external noise source. So this statement is wrong. Short noise is an internal noise. Noise temperature is useful in dealing with ultra high frequency noise. This statement is correct. Thermal agitation is the only source of noise in receiver. Environmental noise is also a noise in the case of receiver. So statement C is wrong. So among this, the option that is going to follow is option 1 is correct. Nothing but noise temperature is useful in dealing with ultra high frequency noise. 58th question, an SCR is connected across 200 volt battery through 0.2 Henry inductance. If latching current in the circuit is 3 milliamperes, what is the minimum width of the gate pulse required to properly turn on the SCR? Now look at over here, this SCR is made up of PN material. Now if you are biasing, now look at over here, when you start biasing or when you start increasing the voltage, this junction J1 and J3 will be forward bias, but this junction J2 will not be in forward bias, nothing but it will be in forward blocking mode. So in order to make it forward bias, what you have to do is you have to apply a very huge value that is in the order of hundreds of volt. So in order to reduce this, what you are going to do is you are going to inject a gate current. You are going to inject a gate pulse current. So what is the width they are asking? If you are maintaining some tens of volt and if you are providing the gate current, the SCR will be in forward bias state. So what is the voltage they have given is 200. So what is the voltage across inductor? It is V equals to L into di by dt. What is the voltage value? It is 200. What is the inductance value? It is 0.2. What is di? Nothing but d by dt of 3 milli divided by width. So on integrating, what I will be getting is T, which is equals to 0.2 divided by 200 into 3 milli. So this is 100 times and this is 0.1. So what you will be getting is 0.003 milli. So the width should be 3 microsecond. So the corresponding option that is going to follow is option 3 is correct. So in the case of SCR, you need to talk about snubber circuit, and two major things what you have to talk is what do you mean by di by dt protection, what do you mean by dv by dt protection. Go through any previous year question paper, at least you can find one question on SCR. So most of the time they will be asking about dA by dt protection and dV by dt protection, or if they are not asking about dA by dt or dV by dt, definitely they would be asking for snubber circuit. But in this year they have asked with the problem. 59th question, what is the speed of satellite moving in an elliptical orbit at perigee and apogee they are asking. We know that the satellite speed will be more at perigee and it will be less at apogee. So this is one thing what you have to remember. And in the case of satellite communication, it is a power limited communication, nothing but satellite will be getting a power with the help of solar cell. And one more thing what you have to remember is uplink frequency will be always maintained as more when compared to downlink frequency. Why you are not going to maintain uplink frequency and downlink frequency as same? Because it is going to cause a distortion. So you are going to maintain uplink frequency different from downlink frequency, but you are going to maintain uplink frequency as greater than or more than downlink frequency, just because the satellite communication is power limited communication. So based on this, if I am choosing, I will be getting option B as correct. 60th question, if the desired transmission bitrate for a coherent binary FSK system is 4 kilobits per second, the best possible interval between the carriers is they are asking. So it is given by 2 divided by RB. So which is equals to 2 divided by what is RB? It is 4 kilo. So what you will be getting is 0.5 millisecond. What you will be getting is 0.5 millisecond. So for this, the corresponding option is option 2 is correct. 61st question, the evaporating rate R from the clean surface is related to the equilibrium vapor pressure, that is PE in Pascal, of the evaporating species, that is M is the molecular weight in gram, is derived by a relation they are asking. It is derived by a relation, that is R, which is equal to 4.43 into 10 power minus 4 into M divided by T whole power 1 by 2 into PE. So for this, the corresponding option that is going to follow is option A is correct, nothing but the statement A is correct but C is wrong. The transfer function of an electrical low pass RC network is given by. What do you mean by low pass filter? R followed by C. So this is R and this is C. Let me take a Laplace transform. So R Laplace transform is R only, but C Laplace transform is 1 divided by SC. So let me take this one as input node and this one as output. So how can I define transfer function? Transfer function is defined as Laplace transform of output to Laplace transform of input. What is Laplace transform of output? It is 1 divided by SC. So what is the input? It is R plus 1 divided by SC. So I will be getting 1 divided by SC whole divided by RSC plus 1 whole divided by SC. So what I will be getting is 1 divided by SCR plus 1. So that is statement C is correct. but none of the other statements are true. So this question is a grace question. So for this, none of the option is correct. 63rd question, what they are given is, by applying principle of superposition to the circuit, you have to calculate voltage across resistance R. For this UGCNET board, they are given the answer as 1 volt, nothing but option D is going to follow. Since I don't know the value of capacitance, I can't calculate the voltage across this resistance. Since in the response sheet they have not given the value of the capacitance, I can't find the voltage across this resistance. If you are knowing the value of this capacitance, please share the value in the Telegram group. I am going to provide the solution for this problem. 64th question, following statements are given for electrodynamometer type instrument. What they are given is, it is used for AC quantities only. No, it is not used for AC quantities. It is used for both AC and DC quantities. It can also measure power and frequency. This statement is correct. It has only one coil. This statement is wrong. It will be having multiple coil. So the corresponding option that is going to follow is statement B and C is correct. Nothing but option 2 is going to follow. 65th question, the resistivity measurements are made on the flat ends of the crystal by the 4-point probe technique. The current J is passed through the outer probe and the voltage is measured between the inner probe. If S is the probe spacing in centimeter, the measured resistance is converted to resistivity using the formula. The formula is V divided by I, nothing but it is R into 2 pi into S, where S is the probe spacing. So the corresponding option that is going to follow is option B is correct. See, you have to be very much familiar with respect to CRO concepts also. Moving on to 66th question, what they have given is, what is the relation between bandwidth, that is B of BPSK signal, and the bandwidth of M-ary PSK signal? We know that in the case of M-ary signaling, what you are going to do is, we are going to save the bandwidth. So it is given by B equals to Bm into log m to the base 2. So the corresponding option that is going to follow is option C is correct. In the case of M-ary signaling, what you are going to do is, we are going to make use of the bandwidth which is very much less. Nothing but we are going to save the bandwidth. 67th question, you have to arrange the work function in the increasing order. Now what do you mean by work function? What do you mean by electron affinity? These concepts are very, very important. Which one is unique in metals and which one is unique in semiconductors, you should know. So if I am arranging the work functions in particular order, what I will be getting is, first I will be getting aluminium, second I will be getting silver, third one I will be getting nickel, and the fourth one what I will be getting is gold. So the corresponding option that is going to follow is option 1 is correct. 68th question, inside this matrix of a graph is given by, so they have given the matrix A equals to, the matrix what they have given is something like this. Number of possible trees are given by, so the answer is option B. 69th question, a 250 megahertz electromagnetic wave is propagated through a perfect non-magnetic dielectric with band gap which is equals to 6. Its wavelength will be equals to. So the wavelength corresponds to 0.49 meter. So the corresponding option that is going to follow is option B is correct. 70th question, there is a spectrum analyzer with a third order intercept point of 30 dB and noise level of minus 95 dB. The dynamic range of the spectrum analyzer is approximately equals to, it is approximately equals to 83 dB. If anybody is knowing the solution for this question, I request you to reply in the comment section. Question number 71 to 75 is based on op-amp. So what they are given is, supply voltages changes because of poor regulation and filtering. For any given op-amp, any change in the value of output voltage or the supply voltage results in a change in the input offset voltage, which in turn causes a change in the output offset voltage. The change in the op-amp's input offset voltage caused by variation in the supply voltage is specified on the data sheet by variety of items. So what and all the things we have to consider is, we have to consider input offset voltage, we have to consider sensitivity, power supply rejection ratio, that is PSSR, and supply power rejection ratio are some of them. All these terms are equivalent since they convey the same information. Op-amp can work as differential amplifier and can be effectively used with feedback for many applications. Based on this paragraph, we have to answer next 5 questions. So moving on to 71st question, what they are given is, what is the output voltage, that is V0 of the following circuit? So in order to calculate this value of V0, what I am going to do is, I am going to make use of what is this voltage V plus. And one more thing, this op amp is not getting saturated and op amp is in negative feedback. Since V plus equals to V minus, virtual short is valid. Virtual short is valid, as well as op amp is not getting saturated. So virtual short is valid, that means V plus equals to V minus. What is the value of V plus? And one more thing, what you have to remember is, there is no any current that is getting into the op amp, nothing but ideally you are going to assume it as 0. So what is V plus? Let me make use of voltage divider rule, which is equals to VB into this voltage, this resistance, that is 20k whole divided by 20k plus 20k will be 40k. So what I will be getting is VB divided by 2, which is equals to V minus. Now one thing what you have to know is, whatever the current that is flowing in this path, the same current that will be flowing in this path also, because the current that is getting into the op amp will be approximately equals to 0. So what I will be getting is VA minus, what is this potential, that is V minus, which is equals to VB divided by 2 whole divided by, what is the resistance, which is 20k. This is the current flowing in this resistance. This current will be equals to this current, right? So which is equals to VB divided by 2 minus V0 whole divided by 100k whole divided by 100k. 20 ones, it is 25. So let me take a LCM and let me solve. So I will be getting 5 times of VA minus, and again 2, if I am taking LCM directly, I will be getting 10 times of VA minus 5 times of VB, which is equals to VB minus 2 times of V0. So what I will be getting is 10 times of VA minus 6 times of VB, which is equals to minus 2 times of V0. Minus 2, if I am sending over here, what I will be getting is V0 equals to minus 5 times of VA plus 3 times of VB. Nothing but option 4 is going to follow. One more thing what you have to remember is, when virtual short is valid, when virtual short is not valid. Again I am going to repeat, when virtual short is valid means whenever the op amp is in negative feedback and it is not getting into saturation. Whenever you are having both positive feedback and negative feedback, what you have to do is, you have to calculate V written by Vt, which is equals to plus or minus A beta. If it is plus A beta, then it is positive feedback. If it is minus A beta, then it is negative feedback, where A is the amplifier gain and beta is the feedback factor. Moving on to 72nd question, what they have given is the open loop voltage gain of an operational amplifier. They have given AOL, which is equals to 2000, and the noise level in the output without feedback is 102 millivolt, nothing but noise level which is equals to 102 millivolt. This is without feedback. This is without feedback. If negative feedback with beta equals to 1 divided by 40, what will be the noise level at output? So noise level at output, which is given by open loop noise level divided by 1 plus A beta, which is equals to, what is the open loop noise level, which is equals to 102 milli whole divided by 1 plus, what is the value of AOL, which is equals to 2000 into, what is the value of beta, it is 1 divided by 40. So what you will be getting is, which is equals to 2 millivolt, nothing but the corresponding option that is going to follow is option 2 is correct. 73rd question, the ideal value of supply voltage rejection ratio, that is SVRR, of an op amp is 0. We know that in the case of common mode rejection ratio, that is CMRR, ideal value is a very high value, nothing but infinite. Always we are going to express CMRR in decibel. What is input impedance? It is a very high value, nothing but infinite, or practically if I am speaking, it is in the order of mega ohms. What is output impedance? So output impedance of op amp is 0, or it is 50 to 75 ohms practically. So you have to know the parameters. One such parameter is input impedance, output impedance, bandwidth, common mode rejection ratio, power supply rejection ratio, that is also termed as supply voltage rejection ratio. So supply voltage rejection ratio is 0. Hence the corresponding option that is going to follow is option 1 is correct. 74th question, which of the following factors affect values of input offset voltage, input bias current and input offset current? So which and all the parameters is going to affect means it is change in temperature and change in supply, that is plus VCC and minus VEE. Most of the cases what you are going to take is magnitude of VCC and magnitude of VEE, you are going to take it as same, nothing but if you are going for same supply design, you can go for plus or minus 5 volt, plus or minus 10 volt, plus or minus 20 volt, plus or minus 15 volts. Most of the cases you are going to take the magnitude as same. So the factors that will affect input offset voltage, input bias current and input offset current is change in both temperature as well as supply voltage. So the corresponding option that is going to follow is option 4 is correct. Last question, some of the salient features of 741 op-amp are listed below. High power consumption, no, op-amp is going to consume very much less power. External frequency compensation. Statement 2 what they are telling is external frequency compensation. It is not going to compensate anything on the frequency. It is not a phase lock loop circuit. They will not be having any latch up condition. Offset null capability will be there in the case of op-amp US741. So C and D is correct, nothing but A and B is wrong, while C and D is correct, nothing but option 2 is correct. So in this video we have discussed question number 51 to question number 75. In my previous video I have discussed question number 1 to question number 50. In the next part of my video I am going to discuss question number 76 to question number 100. If you followed with my lecture, please give it a big thumbs up. Also share this video with your friends and don't forget to subscribe to my channel Craving Gyan. All the best for exams. Thank you.